Hello and welcome. This is CSCE 310 at the University of Nebraska-Lincoln. I'm Dr. Chris Burke and I'll be your instructor for the next 5 weeks. This is a summer session. Go ahead and feel free to comment on YouTube. It's way over there, so I don't know if I'll be able to pay too much attention to it. But if you are enrolled in the course, you should already be enrolled in Piazza. So if you have any questions, go ahead and post there. We've got the live Q&A going. You can go ahead and post as a follow-up. In fact, if you want to, you can go ahead and test it right now. And if with a question, once I answer it, you can go ahead and resolve that follow-up. So this is the first day of class. It looks like we've got 10 people here live. Of course, the videos will be available immediately after on YouTube. Keep in mind, there are about 36 people enrolled. So if you're looking for a partner, there are plenty of people out there. Just go ahead and post on Piazza and make that connection if you don't know anybody in the class already, because of course it's online and you're never going to meet anybody face to face, at least through me. Today is going to be a course introduction as well as a review of material that you should already have under your belt in order to be successful in this course. First of all, my name, of course, like I already said, is Chris Burke. You can go ahead and call me Burke or Doctor. You don't need to use Doctor or anything like that. You can just call me out on Piazza, say hello. So again, my email and my contact information are available on Canvas and of course on YouTube directly if you want. We do have a GTA with us, Sarah. She will be holding daily office hours just like me. Remember that daily office hours are offered through Zoom so that you can share your screen. You can go into a breakout room. You can use our Zoom room if you really want to connect with your partner. And we can put you in a breakout room and you just can collaborate. You can raise your hand and we'll go ahead and pop in and help you. The hours are posted on Canvas. Again, we are live streaming. All times are Central Daylight Savings Time. All live streams go from 11 o'clock to 12:30. And 1 o'clock to 2 o'clock are my office hours. And then Sarah holds her office hours, I believe, 3 to 4. And this is all daily, Monday through Friday until the end of the course, which is Thursday, August 12th. Okay. We've already talked a little bit about the course format on Piazza and with my welcome introduction video last week. But let's just remind ourselves here how this is going to work. Again, lecture is daily, Monday through Friday, 11 o'clock to 12:30, and this is all Central Daylight Savings Time. My office hours are going to be daily from 1 p.m. to 2 p.m. via Zoom. And again, the link for that, I'm not going to put it here. It's just a complicated bunch of complicated numbers anyway. But go ahead and check that out. You can you don't need a password or anything to get in. And I'll be there immediately following today, starting at 1 o'clock. Okay. Sarah's office hours are 3 p.m. to 4 p.m. via Zoom. All right. As a 100% online course, I've been doing this course for about 10 years now. I've been doing it online for the last 3 or so. Kind of a hybrid mode a few years ago. And then when COVID hit, of course, we went 100% online. And I'll probably be doing it during the summer 100% online going forward because the format has been so successful. But live stream lectures, it's asynchronous, so recordings are available immediately after. All right. And most of our communication will be done through Piazza and Canvas. And other tools that you'll have at your disposal that we'll look at later here are going to be the Web Handin and WebGrader. Right? For all of your programming stuff. We've got everything is already set up and ready to go. I demonstrated a Hello World example last week. Go ahead and check out that video if you need to see it again. But otherwise, it is now 100% working. I'll show it to you again here in a second here. Okay. But first of all, let's take a look at the syllabus. And again, if you have any questions, go ahead and post to Piazza for any even if I don't get to them, somebody else will get to them, or I'll post a follow-up after this live stream is done. So the syllabus is available. Of course, well, first of all, let's take a look at Canvas, I guess. I'm looking at this from a student point of view. Everything is available on the front page here, including a tentative schedule. This tentative schedule will get updated with links to the recordings each day. But you can see where we're going here. All the assignments are immediately available, and you can start. You can download those and take a look at them. Some of them are going to be, or they're all going to have some written component and some programming component. So, for example, here's assignment 1 that is due about a little over a week from now. We've got instructions on how to go about the assignment, what exactly we're looking for. For example, all written answers are expected to be handed in as a PDF through Canvas. Now you can hand type, you can type them up in LaTeX. Great. If you want to learn LaTeX or you already know LaTeX. If you want to type them up in Word, that's fine too. I would recommend against that. If you want to handwrite them, that's fine as long as it's legible. And you take a picture with your phone or you scan the documents or something like that, collate them into one PDF, and you hand that in through Canvas. All programs will have to be handed in soft copy through the CSCE web hand-in, and you can use the web grader to check your work. Again, the hand-in is available here. It's csce.unl.edu/handin, and HANDIN. Once you log in with your CSCE account, you'll see something like this. And I've already got a Hello World program set up here so that you can test the hand-in, but otherwise everything is open and you can start submitting now if you want to. You just have to go to a particular assignment, drag and drop files here. If you need to re-hand them in because you made a mistake or there's a bug or something, that's perfectly fine. Just go ahead and drag and drop them again. It only retains the last copy. Now, it does retain like the last 4 versions of it, and you can actually download them if you need to by clicking on them. But one thing that people do is they delete. I wouldn't recommend doing that because that also deletes the history of it. Just go ahead and hand in a new file. The old files will be overwritten. Okay. Once you've handed something in, of course, you can come over here to the web grader. The URL is available in Canvas as well. Using the same login here, you can select whichever one you want to grade, hit grade me, and okay, I have to, there we go. I logged in a long time ago and now it's been renewed. So now go ahead and click grade me. And it's just a hello world that you can write in any programming language that you want as long as you provide a run.sh file. We've already provided, I think, at least a dozen examples for you so that you don't have to worry about how to go about doing it. All right. If you have any questions on that, make sure that you're posting to Piazza. Otherwise, that's the hand-in process. Let's go back to Canvas here. The syllabus is available. Again, the venue is right here online on YouTube and Piazza, 11 a.m. to 12:30 Central Daylight Time. Excuse me. There's my email address. There's the URL to go to the Zoom office hours if you need help. Sarah's information is available there. Okay, great. And there are a bunch of other resources as well. If there's my YouTube channel, which has a bunch of videos on other CS topics and other stuff I do throughout the year. Here's the live stream link. Otherwise, you can just go to my channel and view it daily. There's the full playlist, so if you need to go back to an old lecture, they will all be collected there. There's the link to Piazza, and yep, it is updated. There's the hand-in and the grader that we just demonstrated. Some other department resources, including anonymous feedback. If you have any questions or concerns and you need to speak anonymously to the department, you can go ahead and do that. Our academic integrity policy and other system FAQs, as well as if you forget your password or you need to reset your password, the account management system is there for you. There is no book for this. There's a recommended book. I think it's Leviton. But there is no required book for this course. I have an extensive, it's not a full book, but it is an extensive set of lecture notes that I'll be working from. That's available for download as a PDF file. It's right here. Other courses that are similar to this course that don't necessarily cover all the same topics, they cover similar topics. Some of the topics are the same. They cover other topics. I may cover topics that they don't, but I've collected them throughout the year. There are 2 Coursera courses that are kind of this course split into 2. If you want to check out their resources as an alternative point of view, or if they have a better presentation on something that will just click a little bit better with you, great, go ahead and use that. There's also 2 free books, Jeff Erickson's Algorithms book, and then, of course, an online book called Open Data Structures, ODS, that cover a lot of the same things that we're going to be covering, cover different things, cover it in a slightly different manner. If you are wanting to learn LaTeX, I've provided some resources to get started, getting started with LaTeX, and some LaTeX templates that you can use. I think that if you used, I think it's Overleaf, if you want a 0 installation LaTeX solution, you can go ahead and use overleaf.com to type LaTeX into the web browser, and then you can download it as a PDF. Again, we're not requiring LaTeX. It's in fact, on such a short schedule, 5 weeks, I would recommend that you not pick up LaTeX unless you have some extra time or you just really want to do it. All right. All the assignments are available here, as well as the example run.sh scripts. I'm not going to go to it because I would reveal some students' names, but make sure that if you are looking for a partner on all of your assignments, not your exams, but on all of your assignments, you are allowed to partner up with at most one other person. And you have to follow the partner policy. You have to work on all problems together. You can't simply just say, you do the even ones, I'll do the odd ones, or you do the programming and I'll do the handwritten ones, right? You have to work on all problems together. You should not discuss those problems to a great detail with other people outside of your partnership. And you only hand in 1 copy. So you'll hand in 1 PDF copy of your written portion to Canvas, and you'll hand in 1 soft copy under the first author's name, the one that comes in alphabetical order, their last name, under the CSCE web hand-in. Okay? All right. So we've got our first question here. Any IDE preference for this course? No. Good comment here, though. I plan to use VS Code with Python. That's absolutely fine. I'm going to do a Python demonstration here in a moment, and I'm just using Atom.io and the command line. If you want to use whatever you want to use, if you want to use, I think, PyBooks or PyCharm or something like that, I forget what they're called, it's perfectly fine to use whatever you want. Okay. On the programming, like I said before, you can use any programming language that you want. In fact, you're highly encouraged to pick up a 3rd programming language that you're not already familiar with, just so that you get more exposure. That could be JavaScript, that could be C++, that could be PHP, etc., etc. However, you cannot use Java. Java is the 2nd programming language in our course sequence, Computer Science 2, and you can use C if you really want to, but I don't think that you want to. That's our first language that we use in CS1 in our department. But doing these assignments is going to be 10 times harder using C than if you just use another library with a more rich collections framework or built in or as a library. But you can't use Java because you've got to learn something new. Now, my suggestion is to pick up Python 3 if you're not already familiar with it. And I'd say that 90 to 95% of the students in the past have used Python. Some students have wanted an extra challenge and picked up a functional programming language like Haskell or Scheme or something like that. You can use whatever you want, just as long as it has to work on the CSE command line, and you have to provide a run.sh script for it to actually execute through the web grader. Okay. In addition, all of your programming, you will be handing in at least two non-trivial test cases. The way that we were able to make this language agnostic is by making it just plain old file input, like all the input is in some text file, and then all the output is going to be the standard output. Whatever happens in between that is completely up to you. You'll have, you'll have your file parser to read in the input. You'll do your magic with your actual program, and then you'll dump everything to the standard output. In order to facilitate that, though, you are required to hand in 2 non-trivial test cases so that you have demonstrated that you at least have rudimentarily tested your own program. The way that the grader is set up is we've got a repository of official test cases whereby 5 random ones are chosen on every single grader run. But in addition to that, it runs it on your test cases to make sure that your program runs on your own test cases. And then it goes out to all of your classmates, grabs all of their test cases, and then runs your program on 5 randomized ones of theirs. So there is a possibility that one of your Gomer classmates hands in a bad test case. You're not responsible for that, though. All right, so just make sure that you are responsible for the official test cases. The good peer test cases is what we call them, and then, of course, your own test cases. Otherwise, everything else is written. Right? So here's the typical assignment 1. There are 4 assignments, one about every week. They are substantial, and they make up about, we'll get to the syllabus here in a second, but they make up about 80 to 90% of your grade. Okay. All right, no questions so far. So let's go ahead and go over to the syllabus. So I've got 2 quotes here that kind of encapsulate or give just a digest version of the theme of this course. The first one is, of course, kind of cliche. Everybody uses this. It's from Edgar Dijkstra. Computer science is no more about computers than astronomy is about telescopes. So computer science is way more than programming. Programming is just the start. Of course, you need to know programming in order to tell the computer what to do. But ultimately, how do you know what to tell the computer what to do? And that's where problem solving in computer science comes in. The second, it's more about math than it is and problem solving than it is about the actual computers. Because, of course, people were doing computer science without calling it computer science for the last 5,000 years of civilization. We had algorithms going, we have some of the oldest algorithms, like Euclid's GCD algorithm, or algorithms that date back to 3,000-4,000 years ago. The algorithms existed far earlier than modern digital computers, and so computer science, even though they didn't call it computer science, existed back then. It was problem solving, it was developing and analyzing algorithms, etc. And then the second one is a little bit more practical. It's a quote by Charles Learson here. If you want to become a good programmer, you just program every day of your life for 2 years. If you want to be a world-class programmer, a great programmer, then you can program every day for 10 years. Or you can program every day for 2 years and then take an algorithms course. And that's how valuable understanding algorithms and data structures actually is. Knowing what you can take off the shelf for a data structure, or recognizing a problem as, oh, I can cast that as a graph problem and then apply this minimum spanning tree algorithm to it, and you're basically just taking off the shelf solutions and solving a problem, a new problem. But knowing that and understanding that and recognizing that, that's where an algorithms course comes in, algorithms and data structures. Okay. All right, so the course information is here. Of course, we've got 2 prerequisites, Computer Science 2 and Discrete Mathematics. This is the official catalog description of the algorithm, or of the course, excuse me. Again, it's data structures and algorithms, but I just call it Computer Science 3 because it's the third in the sequence. Again, the recommended textbook is by Leviton. There are my lecture notes, there's OpenDSA, there's the Jeff Erickson book, etc. So those are the prerequisites. If you are in our computer science or computer engineering program, do be aware that you would need a C or above in this course to continue in the major for both of those majors. So that's a post-requisite that you do need to pay attention to. There's a course overview. There's a list of topics that kind of matches the schedule in Canvas. I'll go ahead and let you take a look at that on your own. There's more details on the course delivery. Again, this is delivered online more or less asynchronously because you don't have to be here live with me. 17 of you are great. Hopefully the other 20 of you watch this at a later date. And hopefully all 17 of you are actually enrolled in this course. I'm not just getting randos on the internet, but if you are a rando on the internet, then welcome. You're still welcome. Daily lectures again are live streamed via YouTube. During the broadcast, I've got Piazza going here. We've already got one question over there that I answered. For assignments that allow collaboration, you may use any medium to collaborate if you choose. If you want to set up your own Zoom sessions, if you want to just use Discord, if you want to use Slack, whatever you have, whatever works for you. If you're actually, in town in Lincoln or in Omaha and you want to team up with somebody else in Lincoln and Omaha and meet face to face, hopefully both of you should be vaccinated at this point. Definitely feel free to meet face to face either at UNL or UNO or your own places, right? You can and in fact should be using Git to share code. Make sure that you're using your own private repos though. There are also free online IDEs that allow you to type in the same window so you can do collaboration coding wise. And there's a list of the REPL supports that. The CS50 IDE I think supports that. And there's a more extensive list available at that URL. Written solutions will be submitted online through Canvas as PDFs. Live office hours are held through Zoom. The exams will still be run, but it'll be an asynchronous take-home exam. So first of all, no collaboration on that. So your partner will have to split up and do their own thing if you're going to partner up. And by the way, you don't have to partner up. You can, of course, have a partnership of one. You can work with somebody on a first assignment. It doesn't work out. They didn't pull their weight, or your schedules just didn't work out. Fine. You can go ahead and find a different partner for assignment 2 or 3, etc. But back to the exams, they will be take home. So I will release them at a certain time. It'll be auto-released on Canvas. And you'll have 24 hours in which to complete them and then submit them through Canvas for the written parts. There traditionally haven't been programming components to the assignments, but you'll have 24 hours to do that. All right. Accommodations for students with disabilities. Make sure that you are registered with the SSD office. If you are, I've not gotten any notifications from the SSD office, so you'll want for accommodations. So you're going to want to contact them immediately since the class has started and I've not heard anything from them. Grading, like I said, the vast majority of this will be 80% is based on those 4 assignments. They are substantial assignments. Basically, take the 6 or 7 assignments that you would have in a regular 15-week session, condense them down to 4 assignments. You're looking at about twice the work of a regular assignment in a 1-week period. So keep that in mind. I would highly encourage you to take a look at the first assignment and get started on what you can now, even though we haven't covered any topics like at the end of the lecture today. The midterm and the final. Final, of course, is cumulative, but heavily weighted on post-midterm stuff. Those are scheduled and they are in Canvas already. You'll see that on Tuesday, that's going to be your midterm day. Tuesday the 27th, it looks like. And then, of course, the final exam, take-home, will be on the last day, August 12th. Okay. Standard letter grades, and by the way, there is bonus available on the last assignment. I believe that there are 250 points instead of the regular 200, but we graded out of 200. So if you're wondering about that, yes, it is at the end, but don't rely on it, right? Standard scale here, there are 4 assignments. No late work is accepted at all. We only have 5 weeks here. In fact, we only have 24 business days to actually do this course. So make sure that you are diligent. Make sure that you are starting early. No lates will be accepted at all. Partner up early if you're wanting to do that. In fact, you can go ahead and post online right now. If you're looking for a partner, I can put up a special thread for it if you'd like. But otherwise, make sure that you are staying on top of those. basically a 15-week course condensed down into 5 weeks. So, you need to be thinking in those terms, that it's going to go 3 times as fast, that it's going to be 3 times as much work, because it's condensed, right? There's not going to be that bacon period where you can watch a lecture, go home, have a couple of days to think about it, stew over, and then revisit it, because there are a couple of days between lectures. We go every day for an hour and a half every day, right? You can break that up. I can't break that up, but of course you can break that up by watching a half hour here, watching a half hour, taking a break, going back and forth, speeding it up if you need to, etc. Two exams, by virtue of them being take-home exams. Of course, they are open book, open note, open computer, but you can't collaborate with anybody inside or outside of the class on the solutions. So far, Sarah will be doing all of the grading. I'll step in occasionally and help out if it's too much. But if you have any questions on grading, make sure that you're approaching Sarah and talking to her about it before bringing it to me. If you can't get it resolved, then please go ahead and talk to me, but do so in a reasonable manner, right? We're not going to, don't wait till the end of the semester to beg points on the first assignment. Make sure that you're getting that resolved early. Again, no late work. Without, maybe there might be some makeup or some accommodations or something if you approach me and talk to me about them first. But I'm flexible. But again, we've only got 5 weeks here. Failure to adhere to the requirements of an assignment in such a manner that makes it impossible to grade on the web. We don't have time to go and debug your stuff to figure out why is this not working. It needs to work on the web grader. If it's because you're simply not reading command line arguments correctly, you should have enough time to go back and fix that. You should give yourself enough time to ask on Piazza, why is this not working? Make sure that you're doing that, because if we can't grade it, we're just going to have to move on and give a 0 to it. Even though if it's 99% there, it's that 1% that matters in the end, I guess. All right. Academic integrity policy. Summer session policy, I've already touched on this, but again, you're going to have to realize that there are lots of differences between the summer session of this course and a regular academic fall session or a spring session. First of all, it's 100% online, which is a challenge to begin with. But then you're compounding that challenge by taking 15 weeks and condensing it down into 5. If you're taking multiple classes, think of that another way. If you're taking 2 classes during the summer session, that means that you are taking 6 credit hours. Map that to a fall session with the same multiplier of 3. That means that you're taking 18 credit hours during a regular session, right? That's a lot of work. If you've got a job or an internship or a part-time or full-time, that's going to count as well, right? So you need to make sure that you are that you're not taking on too much. Again, this course is offered in the fall, online, and I believe online and in person, maybe in a hybrid mode, not by me, but by other folks. In fact, I think there are 3 sections this fall, or maybe there are 3 sections in the spring. So there is plenty of other opportunity to take this course if you're just way overloaded. If you're taking a full-time internship over the summer and taking too much on. So keep that in mind. Other issues would be that there's no student resource center during the summer. Even the online one, it looks like it's defunct to me. I couldn't find anybody. Nothing had changed for the summer, so it's just me and Sarah here to help you and each other. Not only that, but there's no recitation. That might be a good thing in your view. Usually this course comes with an extra 1 hour a week recitation in which you go and either take a quiz or you get some additional help. You talk about other topics in depth. That's not part of the summer course. It's just the lecture and it's just the assignments. All right. So keep that in mind. We have a next question here. Link to the web grader. It's available in Piazza. And yep, there you go. Good. Thank you for a student for answering. So back to here. Communication and getting help. Again, you've got a lot of resources here, but you need to get help in the right way. Make sure that you're watching the lectures. 90% of your questions could be answered in the lectures, or if you attend the lectures live, then you could ask a question and get a clarifying answer there. Make sure that there is no required reading here, but if you can read along in the textbook or one of those other free online textbooks. Make sure that you're reading Piazza. 90% of the time, you've got a classmate that has the same exact question, and it's already been asked and answered, and we'll just link right back to that answer. Right? Don't procrastinate. That's true at any point in your life. It's especially true in college in a regular academic session, and it is vitally true in a summer session that has been condensed down into 5 weeks. Right? Get help the right way. Please read this. Don't just throw up your hands and say, I don't know what's going on, right? Describe the problem. Describe the solutions or approaches that you've already tried and why they didn't work, right? Then we're going to be able to help you a lot easier, right? Otherwise, I've got this is not in this course, but of course I can link to it. It's tips for succeeding in this and other online courses. Again, treat it like a regular course. Don't think, oh, it's going to be easier. I don't have to go to class. I'll watch the lecture at the last minute. It's not going to work, right? Treat it like a regular course. Make sure that you are setting up your own discipline. Like I'm going to watch the lecture every day at 11, or I'm going to watch it every day at 3 o'clock because I can't make that 11 o'clock. Because I haven't woken up yet or something, right? Make sure that you set a schedule and keep to that schedule for yourself. Get and stay organized. Make a plan and keep to it. Some additional tips here. Create a regular study space. So if you're at home and there's lots of distractions, video games, your family, whatever else, try to find a place where you can do this a separate place. Go to your room with no distractions. Remove the TV, remove the computer, whatever, and make that your study space. If you don't have a space like that, go out to Starbucks. Right? Take some headphones with you. Go to the library. Right? And take some headphones with you and use that as your safe study space. Right? Make it feel like you're actually in college, or you're in your dorm, or wherever you do things normally. Right? Let's see. Okay. Something wrong with the run.sh file should be handed in through the web hand. You have to hand in something first before you do anything with the web grader. All right. All right, and the run.sh files examples are available on GitHub, which is linked to in Canvas. Network, connect, and stay engaged. Again, it can be hard all alone, but it's still able. You're the generation now, at least most of you are, that have networked and created meaningful relationships online. You can do the exact same thing with respect to this course. Engage in Piazza. Engage on the department Discord. If you need a link for that, I can post it in the in Piazza as well. But just stay engaged, and now that hopefully you're vaccinated, you can get together face to face with your partner to discuss things, right? And utilize the resources that we've provided for you. Okay, and finally, stay healthy and expect to be challenged. Stay healthy as in make sure that you are taking some time for physical activity and getting out of the house, right? Don't just sit at your computer all day. Take plug here. I think it might be too late to register, but you may still be able to register. A couple of faculty, me and a couple of other faculty, we try to have a run with CSCE faculty every fall and spring semester, weather pending. During this course, we've got the big 10K coming up. You can run 5K or 10K. You can register or something else entirely. Go ahead and post to Piazza with a picture. If you do end up registering, I'll go ahead and post my time. Go out and take a run or a bike or just a walk, right? Make sure that you're staying healthy, okay? Don't cut out the recreation. If video games are your thing, if Netflix is your thing, great. Keep that, but make sure that you're scheduling it around everything else and making time for it, but limiting that time so that it doesn't bleed into everything else. Don't let this course bleed into everything else, your social life or your recreation. All right. Okay. So if you're looking for more resources, again, it's linked on Canvas here. But like summer 19, all my lectures are still there. There's a course link there. All my lectures for summer 2020 are there, where I did the same exact format. The same basic resources are available on this GitHub page as well. If you want to, we recommend that you pick up Python 3. If you want to, you can go ahead and look at Code Academy or Coursera courses on learning Python. I would recommend against picking up, just going with Python 2. Python 3 is where it's at. Okay. All right. That's that. No questions other than people looking for partners. I can put those into one unified post later on. There is a partner post on the front page, not in the live Q&A. Some good comments on YouTube if you want to check those out. There's your assignment. All right, so there's the syllabus. What else? All right, so we're at the point now that I was just going to do a really quick review on what you should know for this course already. Like what should you have under your belt already, that if you don't have a good solid foundation, you may want to consider taking this course after you've taken the other prerequisites. But again, the prerequisites for this course are CS1, CS2, and discrete math. Don't worry about that text at the bottom. That's just because we're in kind of dark mode here. Which means, what specifically do you have to know? You have to have at least some proficiency in programming. You have to at least know at least one high-level programming language, if not 2 or 3. And of course, we were highly encouraging you to pick up another 3rd programming language in this course to do everything. If you already know Python 3 and want to use it, great. I'm not going to I'm not going to say, oh no, you can't do that, because you need to absolutely learn something new. If this was during a regular like fall or spring semester, I think I would require something new. A lot of instructors require C++. That's kind of a bear even in a regular academic year to do. Python 3 is my recommendation because, first of all, it's really, really popular. Data science, blah, blah, blah. But second of all, it's easy, right? The reason I like Python 3 as a 3rd programming language is because it allows you to focus on the data structures and algorithms rather than focusing on the minutia of getting programs to actually work. I don't like it as a 1st programming language because of the same reason. It doesn't allow you to learn how things actually work so that you understand. You're letting the language do all the work for you. You still need to learn programming fundamentals so that when you pick up another programming language where you don't have, say, list comprehensions, that you actually know how to iterate over a collection and process data. Right? Okay, so what else? Well, basic searching and sorting algorithms, right? And merge, sort, whatever. We might review those when we get back to divide and conquer algorithms. But you should know the basics, basic algorithm and algorithm analysis. All right, that's from both CS2 and discrete math. This includes big O analysis, asymptotics. If you've learned big theta analysis, great. A limit method using calculus, great. Whatever. You just need a basic understanding of big O notation and, given an algorithm, how to go about analyzing it. Basic data structures, including stacks, queues, lists, all right, both array-based lists and linked lists, binary search trees, and graphs. Graphs mostly coming from discrete math. We'll get into graph theory again and advanced graph algorithms. but you should also already have a basic fundamental understanding of graphs, you know, that they're these vertices and they're connected by edges, et cetera, et cetera. Right? Basic proofs and logic. Right? That's coming from the discrete math world. You will be asked to prove or disprove things. You need to have a basic understanding of how to do that. And basic combinatorics. Right? You know, n choose k, n permute k, those kind of things that would come from discrete math. All right. So what I wanted to do with the remainder of our time here is to make sure that you, just to give you a sample of what you should already know. Right. And I'm going to take you through the entire process of here's a problem, solve it, develop an algorithm for it, and then analyze that algorithm. Right. So here's the problem. And I'll simply just cut and paste so I don't have to type it out. There we go. Give it a collection of points in the Cartesian plane. Output the minimum distance between any 2 points. All right. So again, you're given all these points in the Cartesian plane, x, y coordinates. And 2 points, they have a distance between them. That's the Euclidean distance. Well, this point and this point have some distance, but if I've got another point here that's closer to this point, then clearly their distance is less. If I gave you 100 points in the Cartesian plane, I want you to go through and find the 2 closest points. Okay. Now points can be coincident, in which case there's the distance 0. We're not talking about that. We're talking about distinct points. Okay. So again, to visualize this, and unfortunately I'm going to have to go low rent here because my iPad is not working. Well, it works fine with OBS, but it slows everything to a grinding halt, as you saw last week. So again, you've got a bunch of points in the Cartesian plane, and the distance between them is defined as the Euclidean distance, which is the square root of their x components, x1 minus x2, the difference of their components squared, plus y1 minus y2, if this is x1, y1, and this is x2, y2. And that's squared, and then you take the square root of it all. That's the distance between these 2 points right here. What you want to do is you want to go through and find the 2 points that are closest in distance and output that distance. All right? That's the basic idea. So first of all, let's think about this problem, because the first thing you do is not to write an algorithm. The first thing you do is understand the problem and then have a solution written out on, literally in this case, a piece of paper. Right? So if I've got, say, 4 points, right? How many distances do I have to consider? I have to consider this if this is A, B, C, and D. If I've got A to C, I've got A to B, A to D, right? You don't consider A to A itself because that distance is trivially 0. You've got B to D, B to C, but you've also got B to A, but you took care of that when you took care of A to B. So in other words, we're looking at pairs, right? And then the last one, of course, would be here to C to D. We want to examine all pairs of points, right? We also want to compute the distance. For that, in the previous page, I already gave you the formula for that. That it's a square root, blah, 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 right? And what you'll do is you'll compute the distance here, 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 and here. And you'll keep track, right? Keep track of the smallest and update if you find a closer distance, right? And then at the end, once you've examined all pairs, then that's it. You output the distance. Now, of course, variations on this would be you can output the actual points that give you that distance in addition. Here we're just asking for the actual distances. All right. So I think we have a pretty good understanding here. The next step in problem solving here is to write an algorithm. Now, writing an algorithm involves writing pseudocode because, again, we haven't gotten to the point where we're writing code yet. We're going to write Python code here, but we're not writing that yet. We are writing an algorithm, and an algorithm uses pseudocode. Right? Pseudocode, clearly, there's no hard and fast rules for pseudocode. Otherwise, you would have a programming language. So, but some good guidelines here would be to clearly label the input. The input will be a set, a collection of 2D points, Cartesian points. And I'm going to give that collection a label, right? I'll just call it P. And I'm going to give each individual point also a label. X1, Y1, X2, Y2, dot, dot, dot. And then XN, YN, excuse me, for the last one. All right. This is a pretty fat Sharpie. Let me know if it's not legible. I've blown it up here as much as I can. All right. All right. That's the input. Our output will be the smallest or the shortest distance between any 2 points in P. Now, again, you could have a variation on this where you are keeping track of not only the distance, but you're also keeping track of the 2 points that gave you that distance, in which case you can output point A, point B, and their distance, right? We're just going to keep it simple here, though, right? All right, so how are we going to go about this? Well, exactly as I described it before. We're going to have to, first of all, we're going to have to keep track of the distance, right? So I'm going to go ahead and create a variable here called min distance, or dist for short. And I'm going to assign it a value that initialize it to something. Now, if I initialized it to 0, then no other distance is going to be less than that, right? There's no such thing as, and there's also no such thing as a negative distance, right? At least not with regular old Cartesian geometry. So what I'm going to do is I'm going to make this really mathy. I'm going to assign it infinity, right? Any valid distance between 2 points is going to be strictly less than infinity. So if I find something, the 2 points that are closer, then I don't need to worry about this initialization here, right? Again, oh, what's that thing right there? That arrow. Not all programming languages use the equals operator as the assignment operator. So I'm using pseudocode here to keep it away from any particular programming language. I'm just going to keep it as general and generic as possible, right? Now, how do we iterate over all of these points? I don't know. That's a programming question, not a pseudocode question. A pseudocode answer to that would be for each pair of points, P, and I'll call it A, and PB, and hopefully you've taken 235 and have seen this set notation here in P. Do the following. Now, colon's optional. That's kind of Python-y right there, but I'll go ahead and allow it. Right. What I'm going to do is I'm going to compute the distance. And I'll just use delta as a placeholder for that. And I'm going to use math, right? So, in fact, I'm going to now, at this point, I'm going to rename these. Well, no, A and B, I'll go with XA minus XB. Implicitly, that's going to be the X component of point A and the X component of point B. Square that, and then add the Y component at YA minus YB squared. The order here doesn't matter because it's just a difference and you're squaring it. So, right, you could switch those around and it'd be the same. Right? All right, so that's my distance between those 2 points, right? If that distance is less than my min distance, then I'm simply going to update min distance to be delta. You'll also note here that I am using this kind of notation in my pseudocode instead of brackets. Lots of programming languages use brackets, C-style brackets. Python uses indentation and colons. Pseudocode, when I write my pseudocode, I want it to be absolutely clear that this is not any actual programming language. There is no way to get this typing in a programming language. Lots of IDEs support that, where they have blocks and you can collapse them and expand them. But this is definitely, you're not going to get this in any programming language. So it is absolutely clear that this is generic and general and abstract. Right? At the end, after checking every single possible pair, I will output delta, at which point I'm done. Right? That's the algorithm. Right? Once you've got an algorithm, of course, you can start furiously typing and getting your code done. But before we do that, I want to review how to analyze an algorithm. Right? So algorithm analysis. I like to give a 5-step process. It's similar to Levitin. So algorithm analysis. Step 1, is you identify the input. Let me make sure that this is formatting correctly. There we go. That's basically a freebie, right? Because if you wrote good pseudocode, the input is already identified very easily here, right? You identify the input size. And again, if you are writing good pseudocode, then that has already also been identified. There are n points here. Now you might be able to say, well, wait, there are actually 2n numbers here, right? Yeah, but the input, when you analyze the algorithm, there's just going to be this 2 sitting out front here. We don't care about that when we go to big O analysis. So keep it simple. If it's a collection, it's the size of the collection. If it's a number, it's the number of bits required to represent that number. If it's a graph, it could be the number of vertices in the graph or the number of edges in the graph, right? Okay. Take some questions. People just looking for partners so far, it looks like. Okay. You identify the input size. 3, you identify the elementary operation. Right? An algorithm can be doing a lot of things. An algorithm could be, for example, doing comparisons. It could be doing square root calculations. It could be doing multiplication. It could be doing subtraction and addition, right? It could be doing a lot of things here. Focus on one, right? If you want your focus to be this distance calculation, great. If you want your focus to be this comparison, fine. That's fine too. In this case, it'll lead to the same exact analysis. You could, depending on your choice of elementary operation, get one analysis that is big O of it's linear, it's order n. Using a different elementary operation, you could come out, well, that it's order n squared, right? And that is perfectly fine. Both of those are valid analysis. It's just that you started from a different starting point by identifying different elementary operations. There are some elementary operations that are more obvious than others. For example, the assignment here, no, that's necessary for the control structure of the algorithm. Anything to do with actually executing this loop, probably not appropriate. What are you're doing work inside the loop, right? Focus on that, okay? But just identify one elementary operation. Don't make it complicated by saying, all right, we're going to analyze all additions and multiplications and square root interpolations, et cetera, right? Analyze how many times, this is step 4, the elementary operation executes with respect to the input size. And just as a placeholder here, we're always going to use n. Oh, whoa. LaTeX is not working here. Ooh. I must have LaTeX shut off, so I'll go ahead and use this instead. There we go. We usually use n as a universal for the input size. It's not x because x can have, non-integral values. There's no such thing as an input size of 3.5. There's no such thing as an input size of -5, right? So we use n because n is usually associated with integer values and non-negative integer values, in this case, at least with respect to algorithms and algorithm analysis. Step 5 is you provide a big O, or if you want to, big theta. Huh, definitely not working. If I do it like this. Nope. All right, my LaTeX rendering in my Markdown is not functioning right now. Oh well, I'll get it fixed and we'll have it back next time. Analysis of the algorithm, right? And that simply just means, you know, setting up a limit if you want to use the limit method. For the most part, 90% of what you do is going to be in obvious land. It's n squared, therefore it's big O of n squared, right? And you don't need to necessarily provide a full proof. If you're asked or directed to provide a full proof, then you absolutely do need to, right? So let's go through that process for the algorithm that we just developed, right? Feeling pink today. Here we go. Right? That's because it's the only color I have. All right. So what's my input? It's going to be the collection P. Right? 2, what's my input size? Well, it's going to be the cardinality of this collection. There are n elements in here. N, right? We're not going to go with 2n because that needlessly complicates things. 3, what's my elementary operation? And by the way, I would love to start using my iPad. If anybody knows how to optimize an iPad input along with, I think I've got 3 webcams and then 2 external monitors, all high resolution, widescreen, and then of course the computer itself. The problem is that Apple, I'm on this is on Macintosh, by the way. So iOS throttles everything to make sure that it doesn't heat up. I've also got a nice cooling pad here, but it doesn't matter even if the temperature is. It's not even warm to the touch right now, but it's still throttling me a little bit. So I have not found an easy way to shut that off. In this case, what's the elementary operation? So what I'm going to do is I'm going to go back and, with the same pen here, number the lines. There we go. So this is just an assignment and it's an initialization, probably not appropriate. Anything to do with a for each loop, keeping track of indices in an actual implementation, something like that, it's probably not appropriate because that's necessary to the control structure of the algorithm. It could be, the square root here, or the multiplications, or the subtractions and additions. Among all of these arithmetic operations, probably the square root is the most expensive. So if I had to choose between everything that's going on here, it would be definitely that square root right there. Right? In addition, there's also a comparison and then another assignment. So you can't go wrong by selecting either the square root or the comparison here, but I'm going to go ahead and go with the comparisons. Online, and this is 1, 2, 3, 4. There we go. How many times is that executed with respect to the input size? Right? Now, I don't have a nice for I running from 0 to n minus 1, for j running from I plus 1 to n minus 1, blah, blah, blah. Who cares, right? This is pseudocode. Right? Now it's time to put on your combinatorics hat. For each pair of elements in a set or collection of size n, we have something that tells us exactly how many iterations that will be. And choose k, right? If you want to go back to the original example where we had 1, 2, 3, 4, right? We had 4 points and I need to choose 2 of them, right? That's n choose k. Well, that's going to be 4 factorial all over 4 minus 2 factorial, 2 factorial, right? It comes out to 6, right? For that particular example. In general, you have that this is n factorial, and you don't have to write out this in general. I'm just reminding you this is a review. So it's n factorial over n minus k factorial, right? But in the actual answer here is that we're not just looking for subsets of size k. We are looking for pairs. n choose 2 pairs. And when I plug 2 for k into this and cancel a bunch of stuff out, it's n times n minus 1 all over 2. Right? Now step 5, when you go to analyze this thing, right? What's the most important term here? If I bring this down over here, this is n squared over 2 minus n over 2. Right? This n squared term here is going to be way bigger than this one over here. Right? In addition, what about this 1/2? Who cares about constants? That big O analysis allows us to ignore those constants. So ultimately, this is going to be order n squared. Right? And that's I did a lot more steps here than I would expect. But of course, if you're going to set up a formal proof of this, we can do that as a review tomorrow if you really want to. But otherwise, it's order n squared. And again, if you want to, you can go with theta n squared. That's a little bit more accurate, right? Okay. The last step in problem solving, at least in computer science, is to actually implement this, right? I've already set up a few scripts here. Just a second. A few items here and this is Python 3. I've imported the random library so that I can generate a bunch of random points. Points are going to be tuples in Python. The parentheses here, you can make tuples. You can make pairs. You can make triples. You can make quadruples. You can make they're all ordered pairs. So just by using that syntax there, really nice syntax in Python. And what this does is it creates a new list. Lists are going to be square brackets. Lists are ordered, and they're generally 0 indexed. So what I'm going to do is for I in range. Range is a nice little function that creates an iterator for 0 up to n minus 1. So it's basically Python's idiomatic way of doing a basic for loop for I equals 0. I is less than n, I plus plus, right? With Python, indentation matters. I'm doing the default indentation here of a tab. If you want your indentations to be spaces or double space or whatever, you just have to be consistent about it. A colon here says go to the next line and do this thing. Right? So I'm just I ask random to uniformly generate a number between -1000 and +1000 for the x component, and then for the y component. And it returns this result. So however many points you ask for, that's how many points you're going to get. I've also transcribed the getDistance function here for convenience. Oh, and I didn't import the math library. There we go. Math.square-root, SQRT, that should look familiar. Given point P and Q, compute the difference between their x components, the difference between their y components, square them up, and then take the square root. Okay? All right, so what I want to do now is to actually implement the algorithm that we developed over here. So let's go ahead and do that. I need, of course, a bunch of points. So what I'm going to do is I'm going to create points is equal to get random points. And we'll go ahead and start out with a small number so that we can debug this. Right? In fact, you could go ahead and print points and see what it looks like. My default Python on my computer is 2. To get Python 3, I have to use Python 3 explicitly. Right? I've got both versions on my computer. On CSCE, the default is going to go to Python 3. So if you just type Python, right, then you'll get Python 3. If you really, really, really want Python 2, then you can explicitly go with Python 2. Okay? So I'm going to run Python 3 on closest pair.py. There we go. So you can see that the first point was 262 and some change, and negative 634 and change, blah, 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 right? So I'm actually generating these points. Great. Iterative development, debugging, right? Print, poor man's debugger. If you get a full IDE, of course, that's going to be necessary here with my Python setup. If you get a full IDE like VS Code or something like that, then you should be able to go through properly debug your Python scripts. Right? Okay. So I'm also going to want to this is not part of the algorithm, but what I want is to I'm going to use the time library to time how good my algorithm is. By the way, this is a terrible algorithm, right? Order n squared is really not acceptable even for moderately large data. And we're going to see why later on. You're going to program a better solution, a divide and conquer solution later on. But we're going to see why it's so bad. I'm going to record the start time before we start looking at the actual points, but after we've generated the points. Time gives me the current time. And then when we're done, time, and then the difference of end minus start, right? Is that right? Yeah. End minus start is going to tell me how much time it took to actually execute that. I believe that it is in seconds, but I'm not sure. All right, well, let's start transcribing this thing. Min distance, we initialize it to some very large value. In Python, inf is a value that you can compare with. So min dist ans, right? We're not paying by the character here, so we don't have to abbreviate, is equal to math.inf. Right? Since I'm already pointing in the math library, I'll go ahead and go with math.inf. There is a negative inf. Any number, any valid non-infinity number is going to be less than math.inf. Right? Next, how do we do for each? Now, it's not. There's not a nice piece of syntax in Python 3 that I know of that says go over every possible pairing, but make sure that if when you go A, B, that you don't also repeat yourself and go B, A. And also don't pair something with itself. So we don't want to look at point A and then compare it to point A and get a distance of 0, because that's going to be a trivial answer every single time. So this is going to be a traditional for loop. For I in the range n minus 1, right? Remember that we have n points here. For j in the range of I plus 1 up to n. Let me explain both of these before we go on. This is going to run I from 0 up to n minus 1 inclusive, right? N minus 2, n minus 2 inclusive. It's going to run one less than the value you give it. A range, if you give it one value, it's going to run up to one less than that value. So range of 10, that's going to run from 0 up to 9, right? Why did I stop short? Why didn't I go all the way up to n? Well, think about comparing that last point there. There's nothing else to compare it to. So I want to stop one short and compare n minus 1 to n so as not to run off the edge of this this collection, right? Why did I start? Now, range is very versatile. You can actually give it a starting point, you can give it an ending point, and you can even give it an increment. Like, I don't want to go up by 1 every time. I want to go up by 2s, right? So you could provide a third argument for that, but of course we want to look at every point, so I'm going to go up by 1s, which is the default. But why did I start it at I plus 1, right? Well, again, if you compare A to B, there's no reason to compare B to A. So I'm going to start and look at all the points. Here's point A. I want to look at all the points after it. I don't want to look back, right? And then I do include n up here, which goes up to n minus 1 to include that last element there. Over here in our pseudocode, we numbered 1 to n because that's pseudocode. That's math. Over here in Python, Python is 0 index. So elements in a list start at index 0, and they go up to n minus 1 if there are n elements in there. Okay. Okay. All right. Let's see. Okay. So once we've got once we've got our for loop here, great. Now we need to calculate the distance. That's why I pre-wrote this. So what I'm going to do is I'm going to get the distance. I'll just call it delta because that's what I used in my well, let's call it distance, right? Because that's what it is, right? Get distance between point. What are my points? Points sub I and points sub j. Right? There we go. You'll see me get in the habit of using semicolons. In Python, it's acceptable, but it's not idiomatic, right? So just get rid of those, right? I think that ultimately they're ignored, right? Okay. And if the distance is less than the min distance, right? Even got a code completion here in Atom.io, then I will simply update the min distance. And that's it. Again, the indentation matters in Python. So all I have to do is go out of this. I don't have opening and closing curly brackets. And I'll report, actually after the end time here, I will report print that the min distance is, and then you can go with a comma delimited list here, distance. If you want printf style formatting, you use a percent, I think it'd be like percent %f, and then you use a percent after this, I think. That's off the top of my head. Let's find out. Oops. Yep. Yay. All right. There we go. So there's the min distance. Right? How do I know that that's correct? I don't. I would want to debug this and be absolutely sure by creating my own test case, right? With a whole bunch of points that are very, very far away, except for these 2 points that are exactly distance 1 away, right? I can manufacture my test case in such a way that I know what the result would be without having to do a lot of thinking about it, right? Generate a lot of random points that are way far away from each other, and then 2 points, throw those in there that are only a distance 1 away. And if I get an answer of 1, I have a high assurance that that actually works, right? Let's also print the time. It took, I'll use the other style here, diff. There we go. I think that I think that that's seconds, right? It's a very, very small number here, so I imagine it is seconds. Okay. I am reasonably sure that this is correct, right? Oh, by the way, you also have string concatenation if you want, so you could have done it like this instead. But this is not going to work. It's going to complain about this, I believe. Yep. Because you are mixing types. That's string concatenation, all right, in Python. But the left thing it took, that's a string, but diff is not a string. That's a number. So to convert it into a string, you have to explicitly surround it with str. And then it's happy about it. Right? That's one thing I hate about Python, is that it doesn't automatically infer that that should be string concatenation. Right? No, it is not a Python course. I'm just giving you a review and potential tips on picking up Python. Right? All right, so great. Now, remember I said that this is a terrible algorithm. Why is this a terrible algorithm? Why is n squared so bad? Think about it in the following terms. If it takes, say I've got 100 points here. If I double that to 200 points, right? And it took, say, 1 second, which is way overestimate over here for 100 seconds. But say that we've got a really slow computer, right? I'm doubling the input size. What would be my expectation here for how many seconds it takes? Well, remember, it's n squared, right? So if I'm going to go ahead and double the input size to 2n, that means effectively that it's going to take 4n squared times, in other words, 4 times as much time as it took with an input size of 100. If I go tenfold, right? If I go from 100 to 1,000, 10 times as big, then that's going to be 100 times slower, right? That's 100 n squared, right? 100 times slower. And you can actually observe this, right? And that's why I set it up like I did here with Python. Let's go ahead and time it for 1,000 points. Reasonable, okay? That it took 0.5 seconds, right? It was noticeable. What if I went up to 2,000 points? Right? Now, based on our analysis over here, I've only done it twice as big. So it took half a second before. It's going to take 4 times as much, right? This is 4 times slower. So it's going to take, I predict, about 2 seconds here. It's about right, right? So what if I went up to, now remember, 1,000 took a half a second. What if I went up to 10,000? Right? While we're waiting for that, if 0.5 seconds before, and I've got a multiplier of 100, then how many seconds is it going to take now? 50 seconds. Right? Now, I'll go ahead and let it run in the background. But while we're letting it run in the background, that's unacceptable. 10,000 points, right? What if I had big data? What if I had 1 million points, right? We're now talking weeks or months or days or weeks to get this done. What about 10 million? That's 10 million, right? Yeah. What about 10 million points? Now you're talking about 100 times even slower, right? Now you are talking about months. What if I had 1 billion? Now you're talking years, right? Maybe 20 years to actually get this done. Not acceptable at all. N-squared algorithms are bad, right? From a practical standpoint. You want to be looking for linear, which are going to be much better, or quasi-linear, n log n. That's why we use merge sort, or quick sort, or tim sort, or a bunch of other fast sorting algorithms. We don't use in selection sort, insertion sort, or something else unless there is a very, very good reason to do so, right? So it took 72 seconds. That's close to 50 of what I predicted, right? Of course, it's going to be off because I'm running a million other things, including OBS, which is says that it's not a CPU hog, but it definitely is, right? All right. Any questions? I don't see any. So we will go ahead and conclude a little bit early today. Again, if that all should be a review. If any of that, like, oh, I've never seen that before in my life, occurred, maybe you want to discuss with me during office hours whether or not you're prepared for the course. But otherwise, I will go ahead and open that partner thread. If you haven't already found a partner, you can go ahead and hook up today. And I would say that your goal for today should be planning out the rest of your semester. Semester being 5 weeks from the next 5 weeks. Make sure that you are working every day and that you plan to work every day. Make sure that you have established your partner either today or tomorrow. By the end of the day, you should take a look at that first assignment and think, am I going to be able to do this in a week? Not only that, but am I going to be able to do that 3 more times in the next 3-4 weeks, right? So keep that in mind. The first assignment is due not tomorrow, but a week from tomorrow, the second Tuesday of this class. Okay. All right. Otherwise, have a great day, and I might see you in office hours.